Hi guys, welcome back to the channel. In this video, we will be discussing how to find the missing weight in a perfectly balanced lever that is also balanced on another lever. So the problem asks, what is the mass of the missing weight B in the perfectly balanced lever setup below? The bars are of negligible weight. So we know that in a lever that is balanced, at the pivot point here, so we have this point that is, let's call it pivot 1. And then this point, let's call it pivot 2. We know that at pivot 1, there's no moment. So we know that the moment that this weight produces is equal to the moment that both of this weight produces at this part. And likewise, at this point, we know that the moment produced by A is equal to the moment produced by B. They're both balanced as well. So let's start at point 1 or at pivot 1. So at pivot 1, we know that moment is actually force times distance, right? And force is actually mass times gravitational acceleration. And since we're gonna equate them together, this side and this side, we're gonna multiply both sides by gravitational acceleration. We can actually cancel it off and just neglect it in the equations later because we're multiplying to both sides and it can be canceled off anyway. So at pivot 1, we know that 4 kilograms times the distance from the pivot, 4 meters, is equal to, at this part, what are the masses present? We know that A and B are the masses that produce this moment here. So we're going to equate this together. So it'll be A plus B. And we multiply that by the distance from the pivot. It's 2 meters here. Okay, so that is 2 meters. Okay, it's not this one because this one, the distances here are the distances from pivot 2, not from pivot 1. Here we are taking into account the distance at pivot 1. So at pivot 1, this is the equation. Therefore, we know that A plus B is equals to 4 kilograms times 4 meters divided by 2 meters. We can see that the meters will get cancelled off and we will be left with the mass of A and B in kilograms. So A and B is actually equal to 4 times 4 is 16. 16 divided by 2 is 8 kilograms. That is the sum of A and B. Now, how are we going to take into account the mass of B? Let's look at pivot 2. So at pivot 2, we know that we're going to do the same thing. The moment that is produced by the mass A is equal to the moment that is produced by mass B. So A times 3 meters is equal to B times 1 meter. All right, and therefore, if we're going to express A in terms of B, we know that A is equals to B times 1 meter divided by 3 meters. Again, the meter will get cancelled off and we will get A in terms of B. And A in terms of B is actually equal to 1/3 B. So if we're going to substitute this here, we know that 1/3 B plus B is equals to 8 kilograms. There is technically 3/3 here. So we know that 1/3 plus 3/3 B is equals to 8 kilograms. Therefore, we know that 4/3 B is equal to 8 kilograms. Therefore, B is actually 8 kilograms times the reciprocal of this. If we're going to transpose a fraction to the other side of the equation, we have to multiply it by the reciprocal of that fraction. So 8 kilograms times 3 divided by 4. We know that this, we can simplify this. This becomes 1 and this becomes 2. And 2 times 3 is 6. Therefore, the mass of B is 6 kilograms. And that is how you find the weight or the mass of an unknown object in a perfectly balanced lever on another lever. So that is the solution for the problem. I hope you guys learned a lot from today's video. Thank you for listening and stay tuned for the next one. Goodbye.